Welcome to Netlabs Hub. Today I'm going to configure port address translation in Cisco Packet Tracer, and this is my topology. As you can see, this topology I have already cabled it. You can see this is the internal network. This is the internal network. Then this is the outside network. So this is my router joining the outside network and the internal network. I'll start from scratch. These are the steps that I'm going to follow. The first step, I'm almost done because this is the topology. We are just going to assign the IP addresses. After then we proceed with the other steps. So I will start with the router. There is less or nothing to be done on the switch. Let me begin with this router. I will move to privilege mode using the enable command. Then from there, move to global configuration mode, set the host name, banner, no intruders allowed, no intruders allowed. From there, interface gig 0/0. This interface, the LAN interface, this one. So then IP address, we give the IP address from the segment, from its segment. That's why. No shutdown. Then exit interface. I move to the interface facing the outside network. IP address 41.10.12.1/255.255. No shutdown. Description outside interface. I save my configuration through copy run, startup, or write memory. From here, I assign this IP to this interface. I have already done it. Let us see which interface is this. This is gig 0/enable show running configuration. Let's see, this is the interface. I have already assigned that IP. So I'm done with the first step. This is the first step. So the next I move to enabling NAT on the interfaces. I start with the internal interface. To enable NAT, we use IP space NAT, then we specify whether it is facing inside or outside. This interface is facing our LAN network, so that is the inside. Okay, so I move to the next interface facing outside, IP NAT outside. Okay, from there, so I have enabled the NAT on the interfaces. Then the next thing what I do is to create the access control list to allow the internal network to access the internet or the outside network. So we move to global configuration. That's the mode where almost all configuration on router or a switch is done. So to enable to create access control list, we just say access list. Then we specify the type of access list, whether extended or standard. So for my case, I'm choosing standard, give it 1. Then from there, I permit 192. Then this is the wildcard mask. During my next lab for OSPF for dynamic routing, you'll get to know how to calculate the wildcard mask. So from there, it's okay. I have created the access list to allow this network to access this one. So the next, I'm going to create the default route. To create default route to IP route, the all internal network, next IP. So we are conditioning our traffic to move from the internal network up to this. This is the farthest destination. So the last IP, it will be the IP address of this router. So it will be 4110.12.2. After there, now I'm going to enable NAT and bind to it to the list, the access list that I have created. So IP NAT you can do that to know more about such. So IP NAT, either inside, outside, or pool. So these two mostly are used for port address translation and static NAT. But the aspect of the pool, this is the dynamic NAT, whereby a pool of public IP addresses is created on the router so that it can be mapped temporarily to the internal IP addresses. So on my case, I'm going to say IP NAT, then I choose the inside. I'm going to enable on this interface. After there, source, where is the source? My source is list. Remember, I had created access control list up here. This is it. So this is the source, the entire network. So list 1, then interface. We are not moving with the pool, because when we move with the pool, this is for dynamic. So interface, then we specify this interface, this one, so that my translation is going to happen through translation of this IP address. This is the movement. It is going through this interface gigabit 0/0, then the outside, its gateway to the external router is gig 0/1. So my last interface here, I'll space gigabit 0/1. So that is it. Let me show running configuration. You can see the interfaces configured. The IP route, the default route is this one. Then this is the IP. We've enabled IP on the inside interface through the interface. Then from that side, when we say interface, we say overload. That one means we are enabling the port address translation on that interface. That's use the name overload. Let me save, then test my IP. Let's try to ping the gateway. I think it will work. You see, success rate is 100%. Let's ping the farthest IP, that's 12.2. Success rate is 80, but when we repeat, it's 100, right? Okay, so the next thing I'm going to do, because I want these computers of mine to get IP addresses automatically, I'm going to configure the HCP pool on this router so that the internal users can get IP addresses automatically. So IPDHCP pool steps: you create the pool, you specify the default gateway, then the network through which the computers are going to get the IP addresses, then DNS. Let's give it that for Google, or we can give it for the last. Then we negate this one, we say no, that one. It means we don't want that. We write memory. That is it. Let's now try to. There is one thing that I haven't initiated. Let me exclude IP addresses. So first 90 IP addresses excluded. I expect this one to get IP address starting from 91. As you can see, 91 is successful. This one, this is 92, correct? This is 93. This is 94, right? So while on this computer 92, let us try to verify now NAT. This is how we troubleshoot NAT using show IP translation or show IP statistics. Show IP NAT statistics. So we will be here. We will be here. Then ping 41 10.2. If I told it's reachable, as you can see, it is reachable. So it is reachable because the access list, the access control list that we created on the router, and also the default route that we created thereupon. If at all the packet will miss the specified route, then it will use the default route. So let's verify the translation. So as we can see, you can see when it has happened. It has happened already. 93. It has communicated to this, but you see, if you can see this section, we've got 16. These are ports, so that we just use one public IP, but uniquely we use ports as identifiers. You can see this side, this is the same public IP, but so that the traffic is specified, you see NAT is expiring. The steps are the router makes decision. As you can see here, let's embark on the manual that I created. You can see here NAT. This is it. It maps a public IP plus port to a private IP plus port. So you can see here, this is the public IP, the colon 80, that is the port, then colon 80. It means it is this one is requesting a HTTP web service that is using port 80. Use cases for port address translation. It can be used. This case is used in web servers, CCTV access, and that is it. As you can see, this is the lab that we've been doing. We've been doing this lab. It maps many private IP to one public IP. So it's one way in which we manage the IP, public IP addresses, because public IP addresses are so expensive, and to use them we need to optimize on the usage. So we've got characteristics for port address translation, or sometimes it is called NAT overload. Most common, this is the most common in networks, because in a complex network you will not be given the public IP addresses anyhow. every public IP is purchased. So it is one way in which IP addresses, IP version 4 addresses are conserved. As you can see, many internal IP can be mapped to one public IP. So what brings in distinction is that the use of port. The port serves as the unique identifiers. For example, here, if I told this was 360, that's it was a 3603 or 443 or 22 for SSH or 21 for FTP. So that is it. It means that internal computer is trying to access the file service from from the from the computer that is being identified by the public IP. So these are the use cases when asked maybe in CCNA. These are the issues. These are the cases under which the part on NAT overload works well. So these are the sub minor types of part. We've got the static part, whereby we just take one public to one private. This is mainly for administration. This is for operation, as you can see, and these are the steps it has undergone. So as you can see here, routing decision. So the router decides, are these packets allowed to enter or not? If yes, then it will allow them. Then what happens next is the translation, NAT translation. Once NAT translation is done, then the packets are forwarded to the designated recipient. Once done, then the session expired. You can remember that many engineers miss this in troubleshooting, and it's one of the bottlenecks that gives people headache in real networking engineering, in real network environment. So these are the terminologies that relate to NAT. Static NAT, the mapping happens to one public IP to one private IP. Dynamic NAT, many to many. It means many internal private IP addresses are mapped to many public IP addresses. This is where I said that a pool is created. This is where we use a pool. So from there we've got this. This is now many to one, whereby we use many internal IP addresses to one public IP. So this one happens to save us on the cost, because every public IP, it is paid for. As you can see, IP version 4 addresses are just used for internal communication. If you happen to access the internet, then you need one public IP, and that is where the internet service providers come into the chain. We've got inside. Inside is your private network. So private network is the section. This one is the inside. Let me write there. Inside. Then this is the outside. Outside mostly is the internet. Then inside mostly it is LAN. So these are the terminologies that you should be familiar with while dealing with NAT. Outside, as you can see, I have explained, and these are the troubleshooting checklist. If at all you are in real environment and NAT is not working, the first thing, check if at all the inside and outside interface are well established. If not, check. Sometimes if I configure this one as outside, then this one is inside, I will not be able to ping from this admin PC to the ISP router. That's one way of troubleshooting. Two, verify if the SEL is used in NAT. If SEL is not used, sometimes it won't work, because the package will not, like the router will be in a difficult state to decide whether the packets originating from the LAN are allowed or not. Also, they check translation, how translations are happening. Is it statically done or dynamically configured, or is it NAT overloaded as like the one we are doing. Verify also the routing. If we miss the default route here, if this computer wants to communicate with this router, then there is no default route, then it misses the route. The traffic won't be delivered to this computer. So those are the things that you should check when it comes to NAT. Also ensure the correct NAT type. The configuration for static NAT is totally different from the configuration of dynamic NAT, and also totally far different from NAT overload. So you should understand that these are the checklist you can use that I just did to let you know. If you see that this lab has helped you a lot, comment. Then in need of these files, I can just bundle them and share to you just for reference as we learn together and grow. So let's verify. You see, my NAT expired because the traffic that I initiated, the router made a routing decision, the ACL was verified, NAT translation was done, then the session was closed. But if at all I can repeat, let me just check here. Let it be on this side. Then I verify. So you can see there, this is the router. We will see what happens when we ping the ping the IP address for the ISP, that is 41.10.12.2. Immediately I generate traffic, then these steps starts happening. These are the steps. These steps. The moment I start pinging, then these steps happens. The routing is verified, NAT translation is done, then the packet forwarding is done. Once the packet forwarding process is done, then let me come back, then the session is closed. You see, you can see. You see, NAT has generated, translation has been done here, because the traffic has been sent from this PC3 to the ISP router. So this is how we configure NAT. I can repeat using any, let's ping one. You see, when we ping 41.10.12.1, nothing happens because that is the gateway to the ISP. It is not one of the IP addresses that I had specified, but the moment we ping the exact IP addresses that was specified, you see here something happens. Let me repeat so that you can see well. You see, translation is done. So when I come this side, then show IP NAT translation, you can see this is what happens. So it happens in real time, but this is just the command to show that. Thank you for being with me alongside this lab. If you feel this content has impressed you, if you've learned anything here, comment, subscribe and like, and also share. If you need of this file, please just comment, then share your email, I give you the files.